No, for the quiz is only everything we covered last week and last time, right? About domains. What is that?
How many questions are on the quiz?
I'm not sure. It's 5 pages, right? It's 5 pages. It's finding domains. I mean, everything's, well, not everything. There's some questions I had to take out because, I mean, otherwise it would have been like a 10-page quiz. So it's finding domains from graphs, you know, what we did last time. Solving the equations and inequalities, the absolute values, all those. Intersections and unions and all of those. Yes?
Is it going to be on Canvas? Or?
No, it's in person on paper.
Oh.
Mhm.
If we finish early, can we leave?
Yes, you can leave early if you finish. Yes?
Sir, if you were not here, I mean, what happened? Because the last time when I came, I had been told me
Oh, yes. Well, we'll talk about it later. Okay, question?
Are we gonna review before we do it, or?
No, we need to move on through the factoring and then we will go through the quiz. All right. So, the factoring polynomials by grouping, this one works when you have 4 terms. All right. That's your best friend when you have 4 terms, okay? All electronic devices, again, your phones, put them away, okay? So, let's see. So, to factor by grouping, what are we going to do? We're going to group terms as the names say, as its names say. All right. So, let me group the first 2 terms, and let me group the other 2 terms. What are we going to do? We are going to factor the greatest common factor of every single group. Okay, let's forget about these 2 terms. What do these 2 terms have in common? Okay, factor out the a from there. A times, that's going to leave us with b minus 6. And then plus. What do these 2 terms, the 2b and the 12, have in common? 2. Okay, so that's going to be b minus, also b minus 6. Remember that kind of exercise that we did almost at the, or rather at the end of the factoring the GCF? Remember how I told you these were going to prepare us for the factor by grouping? Well, that's because, check this out. b minus 6, it's another GCF. So this is what we do in a nutshell. Find the GCF of every single group. All right, and then find another overall GCF in this case. So, and the new GCF will be, what's that? B minus 6. All right, B minus 6, parentheses B minus 6, and then A plus 2. So, in other words, the second group of parentheses will be comprised by this factor, the sign, the other factor. So, A plus 2. That's final answer for this one. All right, let's see. Let's look at another example. Okay, for letter B. So again, start by grouping. Typically, it always works to just group the first 2 terms and group the last 2 terms together, and focus on getting the GCF on the first group first, and then the GCF on the second group second. All right, now, what would be the GCF in the first group between z cubed and plus 5z squared? What's the GCF in this case? Z squared. Okay, so factor out 2 powers of z times z plus 5. All right, and then factor out on the second group. Factor the GCF on the second group. What would that be? What is? Just the 3, right? So plus 3, and that's going to leave us with z plus 5. Now, did you see this new common factor, the z plus 5? All right? Okay, so let's go ahead and also factor out that z plus 5. So I'm going to be boxing it or highlighting it so you can see how this common factor keeps working like. All right? That's going to be then z plus 5 times the quantity z squared plus 3. That's our final answer. All right? All right, let's see. So for letter C, again, let's begin by grouping the first two terms. And from there, okay, find the GCF of the first group. Well, I noticed some of you when I was walking around to see your work, some of you were just factoring the x squared and left the 12x minus 20. Okay, let's recall that the GCF that we factor for each group is not only comprised by the numerical, actually squared, right? It's not by the numerical factor, but also, by the variable factor, but also by the numerical factor. So number one, well, yes, the x squared, it's still the greatest common factor. However, between 12 and 20, what do they have in common? Well, I noticed some of you wrote the number 2. Yes, that is true because both numbers 12 and 20 are divisible by 2. However, there's even a larger number that both the 20 and the 12 have in common. What is that number? 4, and that's why we call it the greatest common factor, because we're looking for the largest number they have in common. So that is 4, and that's 3x minus 5, right? Because 3 times 4 equals to 12, and negative 5 times 4 equals to negative 20. Back to the negative 20, and then also the variables x. Also, okay, so for the second group, okay, so here is the thing. One thing you might want to keep in mind here is the sign pattern. Notice how it worked for other exercises. Let me look back at this first exercise. So notice how we had the pattern positive, negative, positive, negative in this order. In this case right here for letter C, notice how we have positive, negative, negative, positive. In this case, you might want to switch this order to be positive and negatives in order to have the same sign on the first term of each group and the same sign in the second term of each group. That way we can easily see the very, very last greatest common factor. All right? So, let's see. So, in order to accomplish that, well, we might want to factor the negative sign. That way, that's going to reverse the signs of these two terms. And, well, between 6 and 10, what do they have in common? 2. Okay, so that's just the number 2. And well, x only appears in the first term, not in the second term, so that's pretty much it. So now 2 times, in this case, 3x minus 5, and then from here, again, see the new greatest common factor. All right. That's going to be, okay, on the one hand, equals to 4x squared minus 2 times 3x minus 5. And well, we may think we're done with it because, yes, we factored out the very last greatest common factor. However, notice how this factor has another greatest common factor a bit further. That is, well, they're both divisible by 2. We can factor out a 2 times 2x squared minus 1 times 3x minus 5. And that's final answer. All right? So the reason I go the extra mile over here, that's because if you input this as your final result, my math lab is going to ask you to, it's going to tell you that although your answer is correct, it's still not fully factored fully factored, actually. Scott?
Does it matter which order?
between 4x minus 2 times 3x minus 5 or 3x minus, no, it doesn't matter because here, let's recall that multiplication, it's commutative. So that is 3 times 4 or 4 times 3, it's the same quantity, right? And let's see, let's look at another example. Again, we have 4 terms. That means we are going to group. We're going to factor by grouping. All right, let's see. So, group the first 2 terms. Group the first 2 terms. And well, that's going to, well, in the first group, notice we have the m squared as our greatest common factor. That's going to lead us with n squared plus 1. All right? Again, think of doing this backwards. M squared times n squared is equal to m squared n squared. And n squared times 1 is going to take us back to m squared. All right? And over here, negative 2 times n squared plus 1. And now, notice how we can see the new greatest common factor. All right, that's going to be equal to m squared minus 2 and n squared plus 1. Okay, okay, there's 2 more. Okay. Let me do one more and then I'll let you do the next one. Okay, letter E. Letter E again, factor. I'll rather group the first 2 terms. And that is and factor the GCF of every single group. So in this case, what does the first group have in common, by the way? The x, okay, just factor out the x. And what about, so we're left with y plus 2. And then what about the greatest common factor in the second group? Any ideas? Negative 1, right? So the negative sign is in common. However, when we factor it out in terms of a negative 1. And I mean, you don't have to write this negative 1 right here. However, I would write it just so you can see how the next GCF is going to work. In the end, I mean, after a while practicing with this kind of techniques, I mean, it just becomes a second nature, and you will be able to see the pattern, what's next, without having to put those placeholder ones right here. All right, so let's see. So that'll be x minus 1 times, what's that? Times y plus 2. And that's our final answer for this one. All right. Recording? Okay. So again, let's group the first 2 terms. And let's group the last 2 terms. And again, now, well, this one has a lot of letters and symbols and numbers. And, well, let's see. It still works the same. Group the first 2 terms and then group the last 2 terms. So, and let's get the greatest common factor for the first group in this case. So what's the greatest common factor in the first group? 2, just the 2. Okay, looks like for the numbers, just the 2. Anything else? 2x. All right. That's going to leave us with, okay, open parentheses, and that's going to leave us with a minus 3b. All right. Now let's look at the second group. But again, notice the sign pattern in this case. The first term of the first group doesn't have the same sign as the first term of the second group. All right. So when that happens, we need to also factor the negative sign on the second group. So number 1, okay, let me factor out the negative to fix that issue and get the same sign pattern. And now we're good to go and see, and rather find the greatest common factor. So what do these 2 terms have in common? Only the y, right? Looks like it's only the y. Well, also the negative, right? To fix the issue. That's going to leave us with another a minus 3b. And hopefully at this point you get the whole gist of this. You know, it's greatest common factor of each each individual group, and then an overall greatest common factor like this, right? And I will keep boxing, highlighting so you can see what and how are we factoring. All right, let's see. So that's going to leave us with 2x minus y and times a minus 3b. And that's final answer. All right. And okay.